All right. Okay. So my name's Kevin. I'm the president of SoDA, the Software Developers Association. That's a club I started. If you guys are interested, you guys can hit up Victoria. She's a treasurer, second in charge. So ask her. The meetings are Tuesdays and Thursdays from 3 to 5. I do record them and I throw up on YouTube. Okay. So today's talk is about ARCore and Unity 3D, and I specifically want to go over augmented faces. Now, to give you a demonstration of what I plan to hopefully be able to get through without any errors, right? That's generally not how it goes, but we'll see. Let me open up this. Plug this bad boy in. There's this actual pretty cool software. So if you have an Android device, you can actually mirror your screen. It's open source and it works pretty well. So that's my screen. So this is what I plan for us to be able to get through. So you can see we have this AR face that's so in low light condition doesn't work too well, but as you can see, it's tracking my face. You know, and the mesh has even some deformities on there. So that's kind of what I'm trying to hopefully be able to get through to today. So that's fine. Demo for that was over. All right, moving on. All right. So who am I? Why you should listen to me or not? So yeah, I'm 26. I'm studying computer science, minor in math. My emphasis is in cryptography and AI. Those are some of the languages that I've worked with, game engines that I've done, used some hobbies. I like to play guitar, and I like teaching. So this is my sort of like resume. So actually, this is my latest contract. Is actually with the Australian government. I'm actually working with the Art Gallery of New South Wales to build an Android app specifically using NFC chips for them to scan their badges and stuff. So that's pretty cool. And yeah, so Reach Game Studios is a contracting company that I work for. They're also based in Australia. So I like work with games and mostly mobile games. And then I was contracted at Google for about a year in 2016. So I actually worked on the predecessor of the software we're actually working with. So I worked on the Google Tango team, and which now became ARCore. They killed it in 2017 or 18. So yeah. So what is augmented reality? So as we all know, you guys have probably played Pokemon Go. You guys have a familiarity of what AR is and what it's capable of. So it's like interactive experiences. Basically, you take real-world objects, like we have this park here, and you just enhance it with computer graphics. For example, like we have this Snorlax there, right? Yeah, so you have multiple sensories, visual, auditory, haptic, stuff like that. So you can have like a plate of armor if you want, and have a vibrating chest and stuff. Cool. So the SDK that we're going to be working with today is ARCore by Google. So this means that this only works on Android devices, and only a select few Android devices. So I'll show you the list here. But if you have an iPhone, don't be sad. I'm trying to work with Anand to actually do another talk like this using ARKit, which is Apple's version of ARCore. So if you have an iOS device, then you could still be able to build this. So if you want a list of the supported devices for your Android device, it's here. So it's pretty massive. So you can go in there and check to see if your device works or not. Cool. So the ARCore does motion tracking and also environmental understanding. So it can pick up planes, so flat surfaces, including horizontal and vertical. It can also do light estimation. So if you turn off the lights, you can actually change the lighting in your game to reflect real-world lighting conditions. Okay. Cool. So you probably need access to these slides. So let me give you access to these slides. So under share, copy this, go into Discord. Where is ACM at? Here. You guys are all in the ACM Discord, right? So there you go, right there. Okay, and let me help you out by hitting this click me. And so when I built this using my Mac. I'm on Windows, so let's see how this goes. As I'm building it, I'll be building it with you guys. So when I did the slides, version 1.14 was out. Now it's 1.15, but just for the sake of keeping things consistent, I'm just going to use 1.14. So let me paste the GitHub here. So you can go here under Assets. Can you all see this? Under Assets, make sure you're on 1.14 and download this one, the one that says .unity package. And so before we get started with that, so yeah, go ahead and download it, but don't click on it, okay? Just save it, hit OK. And I spoke with Anon for you guys to already have Unity installed. So does everybody have Unity installed? Yeah? No? Okay. Well, if you don't have Unity installed, I don't know. All right, so let's go through this, how Unity works. So let's just create a new project. So I'm gonna just click on New. So that's pretty simple. And I'm just gonna call this, I don't know, ACM AR base. Right. Call it whatever. Cool. So how many people have heard of Unity? Okay, it's quite a bit. All right, cool. You should have it. You should use it. You should learn it. It's a game engine, but don't think all it does is games. In fact, a lot of industries are starting to use this because of the ray casting ability that you have for ray tracing. And the graphics pipeline has improved so significantly that they're actually doing small what they call animated films using Unity, as well as Unreal. Either one. I like Unity. It's the simplest probably engine for you to work with. And in fact, this entire demo that we're about to do is zero coding involved. Right? That's how powerful it is. Right? So if you came here learning to code, oh, sorry, but we're not really going to code. But that's the important part of Unity is that the engine is a component-based architecture. So you build components so you can actually reuse things. Okay? And so obviously the people at Google and Unity have already built these components out. So, we're just going to use these components. And do people understand what a component-oriented architecture is? No? Have you heard of object-oriented architecture, right? So it's kind of the same thing, except that when you're dealing with components at a component level, you generally have a container that contains everything, and then that container just contains components. So that's how Unity works. For example, I just created this project. I have this scene. Under my assets, I have the scenes folder. I can open that up, and this is where I'm at. Here is a game object, right, called main camera. If I click on this, I have this inspector tab, and it's basically going to just inspect and allow me to view all the components attached to this. So you can think of these game objects as your containers, and all of these little scripts here that you see are just the components that make up this container called main camera here. Okay, so that's a very, very brief introduction to how Unity works. Cool. So let's look at the slides here. So we'll just go at it step by step. So the getting started part. So create a new project, and we need to switch to Android, right? And that's the thing I love about Unity is that everything is just almost one click, right? So right now I'm on PC, right? So if I build any projects, this would be for Windows only. But I can switch it to Android by just clicking on Android and say, switch platform. And now Unity is ready to build to Android, just like that. And now I have all these tabs, all these screen reference sizes that I can play around with. So I can go to here's my landscape, here's my portrait, stuff like that. So we need to import the package that we had just downloaded. So I'm going to go to my downloads, ARCore, just double click on it, and import everything. Okay. So you'll have a little window that pops up like this, yeah? And I'm just gonna dump everything. So this is gonna contain components, some shaders, some images like textures and stuff, some examples that we're going to play around with. So yeah. Okay. Usually it's pretty fast, but I'm screen recording, right? And I'm running Windows on an external drive, so bear with me. Is anybody having any issues so far? Everybody's okay? Yeah? Good. Actually, I think with OBS I can pause, huh? Hmm. All right, we're almost there. And okay, cool, done. Next, we need to configure the player settings to adhere to what ARCore requires. So we need to do some housekeeping. So the first thing is we cannot. Okay, so this is a brand new project, right? We haven't done anything here. So our project settings, basically the project settings is configuration setup that will persist throughout all your builds, and you can specify specific settings for specific builds. So if you're on iOS or on Android, you can do specific configurations. So if you go to File, then Build Settings, you'll have this Build Settings window pop up. You click on Player Settings, and this will allow us to change some information here. So Unity won't let you build until you change this company name. Okay, just so you guys can remember that, hey, you need to edit this. Okay, can't leave it as default stuff. So since here we're at ACM, so I'll call this, the company name is ACM. The product name, we'll leave it at that. Version 0.1 is fine. Okay. Next, we need to change the resolution and presentation to only allow the orientation for left and right. No, I think I made a mistake there. So we want to just have portrait mode because we're gonna have it on our face, right? Portrait mode. So under here, allow orientation for auto rotation. We'll leave that as auto rotation, but we'll just disable landscape. So this is going to force that the app is always in portrait mode. Okay, which makes sense. I don't use Instagram, but I'm assuming you guys do. So I know that they have these filters, but I'm pretty sure if you tilt the app, it stays portrait, yeah? So this is basically what we're trying to do, right? And that's about it, okay? Okay, so now we need to go to the other settings part, and we need to change the package name, and you can change this to whatever, okay? So let's get to the other settings. Here is the package name. So I'm going to do just ACM, product name, ACM AR bases, just like that, okay? Can't have any spaces, you can't have any dashes, it can only be letters, and you can only have dots. If you need a symbol to separate, use dots, okay? We need to change the min API. So as a note, Google now requires that all apps submitted to the Play Store have to be Android 9 and above. So I think that's Pi. For testing, however, if you have a device that is in that support list that I showed you guys, but it doesn't support Android 9, or if you don't want to update, you can still build for testing purposes. But when you want to deploy, you should test on a device that supports Android 9. Okay? So I'm going to see I have a Nexus 5X, and it only went up to 7 point whatever. So there's Android 7. Okay? And I think I told Anand to also tell you guys to download Android Studio.
He didn't tell us.
Okay, so you need
you're gonna download it.
Android Studio is
Sorry about that. He didn't tell
yeah, that's a okay. So
I would have put like push on the file or something. I don't know if this is this is what because I made him say
so that's fine. So again, I'm gonna be recording this, so when you guys have time to download Android Studio, you guys can. And the reason why you need Android Studio is because, well, one, if you want to build native Android applications, that's the way to go. Okay. They deprecated the SDK manager, so you used to be able to just download the command line tools and just, grab whatever SDK you needed to work with, and that was it. For whatever reason, Google now wants you to use Android Studio to do all of that. Why? I don't know, but it is what it is. So I don't need to have a project open. I just need to go to the configuration and download the proper SDKs. So if you go to configure here, you go to the SDK manager. This is all I need to know. So when building to Android or any type of device, you need to make sure that you're pointing to the correct location. So if you work with like Eclipse, you need to make sure that you set up your environment variables and that you have Java installed, etc., etc. This is basically the same process. So Android Studio will tell you where it placed the SDK. So this is where the SDK lives. So this is where it lives for me. Users, Noir, app data, local, blah, 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 blah. And it tells me also what SDKs I have currently installed. So I guess Android 10 is Q. And then I have installed 7, which is NuGet, which is perfect because that's my device here. It's 7.1, but it'll still run with NuGet. So make sure you have that updated for your device, and you're good to go. Okay? Okay. Cool. Now let's set up the scene. Okay? So the first thing we need to do is we need to delete basically everything in here. We don't need any of this stuff. And the reason why is, so every scene, okay, think of it as a level. Now, Unity uses the scene camera terminology to be like, almost like you're making a movie, like a film, right? You have different scenes, you have different takes, whatever, snapshots. So, but every scene needs to have a camera, or else you get this little, like, kind of warning, hey, there's no cameras rendering, it'll just be black screen. There's nothing to render, okay? And the reason why we need to delete the cameras is because we're going to use the ARCore camera configuration. We're going to pop that in here. So if you see the instructions, it says in the project search bar, which is here, this is your project window, right? you're just going to look for the ARCore device prefab. So you say ARCore, and then here's the device prefab. See? And here's the beautiful thing about Unity is it's just a drag and drop type of system. So just like that, I now have the camera in preparation for my AR stuff. Okay. Next, AR sessions. So sessions. So as you guys become more and more experienced programmers, sessions are basically like background processes. Okay. This ARCore session is going to spin up in the background of your Android device, and that's the ARCore core, right? So it's a service, and so the plugin is going to hook into that service to get all the information about the device's orientation, poses, stuff like that. Okay? So that's basically what an ARCore session is. But in order to hook into that, that's all on Android native side, right? But we're in Unity. We're not on Android. We're on Unity. So how do we hook into it? Well, that's what the component-based system architecture comes into play, right? So we just have a component that will grab the AR session for us, and that's it. It hooks in. Okay. So let's create one. So when I'm building apps and stuff like that, especially with Unity, I like to keep things nice and organized using folders. So I usually create a folder called app, and I dump everything that I'm working with in there. So all the other folders that are just plugins, I know what I'm working with. So everything is just completely separated. So I'll move my scenes folder in here. And now I'm going to go to ARCore, and there's this session configuration file that I need to build. So I'll just click on that. I'll just call this ARCore session config. Call it whatever you want. Okay. There's some configurations that we need to set up. Basically, when Android spins up the ARCore service and we hook into it, we need to send it some information like what camera do you want to use? Do you want to use the front? Do you want to use the back? Do you want it to do plane estimation, plane detection, light estimation, etc., etc. So that's what we need to do here. So in order to do face tracking, however, we need to disable certain configurations. So we need to disable the plane finding, so we don't actually care about, where the camera is detecting a flat surface or a vertical one. We're not interested in that. We're also not interested in light estimation mode. Okay, so we need to just go here, plane finding, disable it, light estimation, disable it. Okay. And then under augmented face mode, we're going to switch this over to mesh because we actually want it, right? This is basically turning on do face tracking. Okay. If you don't do that, it won't do it. And we need it to track the face. That's the whole point here, right? Okay. Next, AR camera filter. This should be filter. Okay. So under, so we will create under ARCore here, a camera configuration filter. So we'll just add that in. Okay. And we have all these options right here, so we need to just configure it. So we need to just disable the require and use depth sensor. So this is for like the more powerful phones that have now on the front camera can actually detect depth, right? By blasting your face with, well, IR stuff, right? Infrared. So we don't need that, right? So we'll just disable that. Because my phone doesn't have that, and if I say require, and if it doesn't contain it, it will either crash, or when I try and install the app, it won't allow it, right? Okay. Cool. So now that we have all of our configurations, we need to tell the ARCore device, our ARCore session here, which configuration files to use. So we can just go ahead and click on this, and we can delete the default stuff because we want it to use ours. So we're going to drag the session into here, just like that, and we're going to drag in the camera filter in just like that. Okay. Now the last warning is going to say, hey, you're trying to use faces, but you're using the back-facing camera, right? So ARCore only works with the front-facing camera. Okay. So we need to change the device camera direction to front-facing. So that's quote-unquote the selfie camera. Okay. Cool. Next. All right. So now let's save the scene. We're going to save it using Control S, right? And always save, okay? You never know what can happen. Okay? Now, we are going to go to the build settings. We're going to say add open scene, so add our current scene, add it to the build list, okay? And I have my Android device connected. And if you ever want to see if your Android device is hooked up and ready, you can run ADB devices. And it'll tell you, hey, it's connected, okay? If you want to, see what your device is actually doing, logcatting is actually a really good way for you to actually track to see what your device is currently doing. So my device is doing a lot currently. So we can just stop that. Oh, Windows, CLS, cool. Okay, so you should learn how to use the logcats, because if your app crashes for whatever reason, you can pull up the logcat and you can start inspecting of at what point did your app crash and why. Okay, so you can start doing bug tracking. Okay. Cool. So now we just have to say build and run. Okay. And I always like to create a folder called builds. Okay. And I like to categorize my builds. So I'm building to Android, right? So I'll call this Android. And I'll give it a name of test, just for testing purposes. And hit save and cross your fingers, right? See how this goes. I have not tested it on Windows. This is all new. So I have no idea. Should work though. It should. Emphasis on the should. Okay. So. Now I think if you're going to build to Android 9, and if you want to deploy to the Google Play Store at some point, right? All the new apps have to conform to 64-bit. So you need, if you guys are really serious about doing mobile development, either for iOS or Android, like the lifeline of 32-bit is dead. Right? So just, if you have a 32-bit laptop, just get a 64-bit at some point, right? So everything you do now is 64-bit, nothing else. Don't touch 32-bit unless you need backwards compatibility, but all these new phones are now 64-bit, right? So build to 64-bit, which means that with Unity, you need to have what's known as IL to CPP, right? And so IL is intermediate language to C++. And in order to build to 64-bit, you're going to need to have the Android NDK. So that's a lot, right? But, you'll learn these things as you go. So hopefully in the next meeting, I can introduce to you Native Development Kit, which is Android's NDK, in order to build to 64-bit. Because as of right now, this build is on an ARM 7, because my phone is an ARM 7, and it's going to be on 32-bit running, right? So we shall see how this goes. You guys are all first-year students?
No, they're mostly juniors.
Mostly juniors? You guys know what the difference between a 32-bit and a 64-bit is, right? Like the register sizes? You guys haven't taken CSC 35 assembly? So you guys should be pros at this now, right? Alright, so you guys know exactly what I'm talking about. Okay. Yeah, so build times are usually quite, faster than this. But again, I'm screen recording, so my RAM and CPU are just taking a hit here. So it says copying APK package to my Nexus 5X, so it looks like everything's going pretty good. So I'm going to bring up my SRC CPU. Oh, yeah, right. I missed this part. You need to enable ARCore support. Because this popped up on my thing. Basically, it's the camera trying to figure out, but then I think the service died. So you need to go all over here under XR settings and then just check ARCore supported. And now with that, we save the project and we hit build and run. Again, oh dang, I was hoping that would be a one and go. Okay. So how many of you guys have an Android device? Just 2, 3? Okay. How many of you guys have iPhone? Now keep your hand up. Do you guys have Macs? So the ones that have iOS, you also have a Mac? Yeah? Okay. Because if you have an iOS and you don't have a Mac, you can't develop for iOS. You just can't. Because Windows can't develop to build Xcode projects. Right? So I think Unreal Engine has like a hack where like you can build an Xcode project, but you cannot actually build it because Xcode only works on Mac. Okay, so for future references, if you're interested in doing mobile development, on iOS, especially because it's a big market, right? You're gonna need to have a Mac. Okay, cool. So I want to show this. Okay, which is what is this program? SCR. SCR CPY. Hey, that's what it is. Cool. So once you run the app, it's going to ask you this. It's going to say, allow our app to take pictures and record video. Now, why is it asking you that? Because we're using the front-facing camera, right? So we want to say allow or deny? Well, allow, right? Okay, cool. Okay. There we go. So there's my face. Apologies. So nothing's happening, right? Or is something happening? So you don't see it because in the background, ARCore is already spinning up. It's running. The problem is that we haven't done anything, right? So at least at this point, we know it's working, right? And in fact, just so I can actually introduce you to some ADB logcat stuff. So let's open up command prompt, another one. So I'm going to say ADB logcat-c. That clears my logcat. So a logcat basically logs all like, you guys work on a program, you say, system.out and you print stuff to the console. Every application that is running on Android will be spitting things out to the console. And Android saves them into a little file, right? And we can access it. So I'm going to clear it because I don't really care. I just want to see what's happening on my Android device currently. So right now, before when I did this, you saw a bunch of stuff, right? But I cleared all that. Now, when I tap on the app, so here is my app right here. I'm gonna tap on it. You see all this stuff that's going on, right? So you can go ahead and read all that stuff, right? So you can see a lot of things going on. In fact, you can see that a lot of these computations are coming from the camera, right? There you go. I'm going to stop this. Okay. And then so when we started up the app, right? So here's Unity starting up at some point here. And eventually it will tell the ARCore stuff to begin initializing. So you can actually see here that for any of you guys that are taking 180 or whatever, that TensorFlow is actually used in ARCore, right, for the machine learning stuff. So this is using image processing. So you can see that TensorFlow is being initialized because that's one of the things that's actually powering ARCore. So you can mess around and look at that and get familiar with it. So far so good. And I put a dope, right? Because there's nothing that's going to pop up, right? So more setup is involved. So in the hierarchy window, so let's look at our Unity scene here. So this is the hierarchy. The hierarchy is any game objects that are in your scene. So if you think of like a movie, you know, like your scene, the hierarchy would be like what's called your set, right? With your props and your actors. That's the hierarchy. They should have just called it set, but whatever. So we need to create a new game object and call it face attachment. So we're going to go here, hit create, just call it face attachment. You can call it tuna, you can call it whatever you want. It doesn't really matter. I just call it face attachment just because it makes logical sense. Okay. Now, Google ARCore provides some samples. So I'm going to use that sample to show you guys, right? So locate the Fox sample provided by Google under ARCore examples, augmented faces, models. So ARCore examples, augmented faces, models. So there's our Fox sample. So we can click on this and we can view it. There's our little fox. Okay. So we can go ahead and drag this in under here, and our fox is somewhere right there. Okay. Now, for some reason, it's broken. Okay. You guys probably don't notice this, but it's broken, so we have to fix some stuff. That's mainly have to do with the materials. So if I click on this fox, this is these meshes here. There are these materials. And this has a default material. Now it shouldn't have that. This needs to have the ear material. So if I drag that into here, there's my ear. Ooh, right. So here's the right ear. So that's also under this same ear material. Yeah. That's pretty cool, huh? Right? And we have our what's it called? Our fur mesh. So that's under face, I believe. No, that's under nose. They misspelled it. They called it noise. But that means nose, right? And here's our other nose. So they need to fix their thing because it's kind of broken. But yeah, there it is. That is going to be overlaid on top of our face. Kind of like on Instagram, right? They have that. Is that what it's called? Yeah, Instagram. They have those. Okay. Cool. So you can do stuff like this, right? And if you're an animator, you can animate the little thingies. So as you move around, you go like that. You can do whatever you want. Okay. So save it. All right. So almost there. So add the ARCore augmented face rig. So we're gonna attach this to here. We're gonna say ARCore augmented face rig. And remember, this is just a component. So again, no coding involved. I just hit enter and it just adds it. I don't have to do anything. Isn't that nice? Okay. And we have to enable auto bind. Auto bind means as soon as this component wakes up, it's going to look for our ARCore session, specifically the camera, and it's going to bind to it. Okay. Let me make sure we save. All right, and then it says next is build and run. Control B. Right. So. Fingers crossed. Fingers crossed, right? I'll have a little fox. Right. Is anybody here interested in modeling or any of that kind of stuff? Yeah, like using Blender, 3ds Max, Maya, you know. No? You should learn. Yeah, that's one thing. That's one regret I have, that I didn't learn it in time. Right now I'm at that point where I'm just like, whatever. But you know, you guys are younger than me, so you guys should probably learn how to use at least Blender, how to make basic shapes. Because all you need to have is your shapes need to adhere to a specific naming convention, like ear, left ear, right, nose, face. As long as your objects are named like that, if you just to throw it in here, they would be mapped to that. So you have your nose, right? You could put like a little clown nose, and regardless of the person's face, if it's super long or whatever, it would always be placed in the correct location because Google knows you. So it's screen copy. Yeah, memorize it. Okay. Moment of truth. And hey, there it is. See how it's tracking my face, including the nose? Right? So that's pretty cool, right? Alright. So let's see what else we can do. Right? So here I was in my room, so I took a picture of that. And there's some other examples, right? So there's this one right here that does this. So if you want to play around with this, there are some more prefabs. Like here's this canonical face one. That's that, right? So we can actually just swap them out. So if I wanted to, I can just disable this, the Fox one, bring in this face mesh that a lot of people thought was creepy. You know, when I first showed them this, like, dude, what the heck is that? It's just kind of creepy, right? Again, all you do is add the AR augmented face rig, hit auto bind, and again, this is also adhering to the forehead left, forehead right, nose tip, you see? And these are bones. And what we mean by bones in the community of like animation or whatever is that if I can actually stretch this, because this is a skinned mesh. So the skin, the vertices on the skin mesh are kind of like, they're locked to these bones. So if you ever play like a game like Call of Duty or something like that, and you like, for some reason, like part of them is like stretching out, or you've seen games, ever seen a game that does that, their just body just starts to warp? For some reason, the bones on the animation are going wacky, and it's just stretching out the vertices on the skin mesh. So right there and then you know that they're using a skinned mesh. Right? So if you're going to go ahead and do some mods on the game, well, now you know, oh, they're using a skin mesh. Right? So I want to add a material to this. I think this material doesn't have anything. No. No, it does not. No. So let's build this out first and let's just see what it looks like. Right. See how creepy my face is going to look like with that mask on there. So does anybody have any questions so far? This is very quiet. Okay. Is this interesting? Yeah? Alright. Well, if you guys enjoy it, then that's cool. Okay. And as you can see, I have done, no coding, right? If you want to do something more complicated, well then you're going to have to code. But at least for basic setups, this is pretty good. Especially as an introductory way for you guys to get exposed to Unity and some advanced topics like, augmented reality. I find that this demo here is pretty good, right? So hopefully, you guys can, start playing around with this, break it, it doesn't matter, and try and see what you guys can come up with, and learn more about Unity and how you can build different apps, right? And modify the scene, make it look cool, right? So I'm just trying to, based off the time crunch I have, I'm just trying to make it look just functional, right? But you guys can take this and do whatever you want with it. So let's go back to my screen recording here. And there it is. Okay. Yeah? Cool. So, is anybody interested in like game development by any chance? You guys? Yeah. So, shameless plug. So again, I'm the president of SoDA, and right now we're kind of like focused on game development at the moment. So if you guys are free Tuesdays and Thursdays, this is the project that we're currently working on. It's called Whack-A-Mole. You guys all played Whack-A-Mole, right? Yeah? Okay, cool. There's like some moles, right? And you just like whack them, right? Well, here we built it for mobile, so it works on Android and on iOS, right? Although I haven't done a lecture on how to build to iOS yet. But yeah, that's our little game, right? So we built this all since the beginning of the semester, like what, February-ish, right? So whenever that was. So yeah, so this is our little game. We also threw it up on. Whoa. So the music's pretty catchy, right? So this is how far we've gone so far, right? So let me switch this to low res because it's killing my thing here. Okay, cool. So yeah, so that's the game. We have these buttons here that you can click on, right? There's a little mole, he's very, very cute. Right? You hit play, then the game starts. You have a little score right here. Boom. You tap on them, and then yeah, they just randomly appear different locations. And yeah, you have 30 seconds, and it's just gonna however many points you can get in those 30 seconds, that becomes your high score, right? So yeah, I mean, I don't know. I think that looks pretty cute. I really like this little mole. Yeah. So it's game over. So it says I scored 90 points. I can hit restart, or I can hit home. I can just hit home. And that's the game loop, right? It just keeps going on and on and on like that. Yeah?
For like things like this, when you're trying to implement like the touch screen or things like simple content like that, is that like through Unity, or it just registers a clip as well?
Nope, through Unity. In fact, I go over that on how we should do that properly. Because you can go, like, you'll find some videos on YouTube, on tutorials, like on Unity, and every time I've ever seen them, because like there was a point when I was trying to learn this stuff, right? And they all hard coded the mouse, and then they started hard coding the finger touches. But little did they know that the Unity UI has an event system, as an input manager that'll handle all this by abstracting things and just calling things pointers. So a pointer could be your finger touching the screen, or it could be a mouse, or it can be a laser pointer, right? The Oculus has those little thingies right here, and they abstract it because they actually shoot a raycast. That becomes your pointer. So you see, so by not saying mouse or finger, now you can have the Oculus. It just literally plug and play. You have these little pointers and stuff like that. Yeah, so that's all done here. And here's the event system here. You have the standalone input controller, input module, and it handles all that for you. So you don't have to handle that, right? Good question. Cool. Yeah, so if you guys are interested in doing any game development or whatever, there's Victoria. You can talk to her about also joining our Discord, right? So our club is free. Don't know, no? So yeah. Anyways, so that's it for me.
Alright, guys.